Good evening. Thank you all for coming tonight. We're glad to see all of you. Tonight promises to be a very interesting evening where you'll learn about 3D printing and various efforts being done in the United States and in Armenia. For those of you who don't know, my name is AZIZBEKYAN. I'm the president of the Cambridge-Yerevan Sister City Association, also goes by its acronym CISCA. We've been around for over 30 years, and during that time, we have had various programs to foster person-to-person relationships between people in the Cambridge area and in Armenia. For example, evenings like tonight, we've participated in the Cambridge Science Festival for the past 6 years. We invite local experts from Armenia to come here, and as we've done tonight, and have panel discussions with local experts on different topics, such as renewable energy and robotics, to name a couple. And tonight, obviously, on 3D printing. We also help schools in the needy villages in Armenia, such as in BERGE. We've helped them with over $250,000 to over 200 schools in the past almost 25 years, thanks to Eva and Jack Manzorian. And we do other programs as well, and you're welcome to check out our website, which is www.cambridge-yerevan.org for more information. So, without further ado, I'd like to turn this over to BERGE, AYVAZIAN, our moderator, who will take over for the evening.
Could you back to the first slide? Yeah, thanks. Hi, guys. Listen, we don't have enough panelists. Would any of you like to sit up at this table? If we do run out of chairs, you can come here. There's enough room, right? We'll just make it longer. Cool. Okay, thanks for coming. Does anybody here know about 3D printing? You do, huh? Okay, anybody who already knows should leave. Because this is going to be educational, and if you already know it, then we don't have to do anything, right? No, cool. All right, thanks. Raf, did you get those batteries to work? All right. My son Rafi is trapped there as the slide advancer at the moment. So you don't need to know who I am. I'm just BERGE AYVAZIAN. And we put this session together to bring a group of like-minded people who think 3D printing is going to revolutionize the universe. I personally disagree with them. Why?
I don't disagree.
You don't? Okay, well, you can stay here then. What I'm saying is, you know, we've had things that do what 3D printing is doing for a long time. We've had machines that bore holes and make forms and shapes and make parts for whatever devices or cars we're trying to make. 3D printing is new, but it isn't revolutionary. To me, it's an innovative way to accelerate and make possible things that we couldn't do before. And we're going to focus on the things that are really innovative, the things that are changing things, rather than the mundane, the everyday 3D printing activities. Although I will say that even taking 3D printing to the masses, even putting it into an educational context, even making it available so that it's as common as your printer at home or your microwave in your house, if that will change a lot of stuff. So we're going to make it, we'll come back at the end of this and see how revolutionary it is, all right? Is that okay? But, you know, the wave of the future, I think it's very much here and now. It's happening right now, right? Cool. Okay, so am I up on the screen? Yeah. So we have a lot of speakers, which means I should get out of the way, right? Let them talk. Thank you. And who's Jack KEVERIAN? You actually are a 3D printing visionary and have been an emeritus, or are an emeritus professor at Drexel University. I went to the University of Pennsylvania, so we were rivals. And it's all right. You're probably more technical than me. But he's got 15 years as a department head and a professor at Drexel, and has done quite a lot of work at 3D printing and has done some work in Armenia. Am I right, Jack?
That's right.
Cool. Are you going to come up here?
If you allow.
I'm out of the way.
Well, thank you, BERGE. I have to start out by taking exception to your vision of 3D printing, because I truly believe that it is an exciting new technology that has the potential to change our lives. The thing is that it's going to depend on your age as to whether you will realize the full benefits of this. Those of us that are at my age or close to my age, which is near 90 this year, will likely not see the full benefits of 3D printing. But the younger generation will definitely have their lives impacted by this technology. And I think I'll make the case for that as I speak this evening. My main focus will be on part manufacturing. This is a very important application of 3D printing, but only one of many applications. And the other applications that are really quite exciting is the field of medicine and the areas of building construction, to name two, but there are many others as well. Let's see. I've given many talks on 3D printing during my lifetime. Most of these have described the various processes that have been developed to print in three dimensions. Tonight, I will allow others, my compatriots here, to speak about the many fine 3D processes that are available today. My objective tonight is limited. It is nevertheless important to comprehend. I'm going to attempt to put 3D printing in the context of historical technological trends in an effort to understand why this technology is a significant game changer. I'll describe its origin, where this technology stands today, and where I believe it is going. I do believe that 3D printing is earning a place with these other milestone events in history. Take a moment and think how our lives would be without these advances. Imagine living in a world without a wheel. No automobiles, no wagons that went out to the west. A life without the printed word. No books, without electricity, without the ability to have the benefit of mass production, without the electronic devices that have shaped our lives, without the internet and its accompanying information age. I submit over the coming years we will experience equivalent massive changes as 3D printed items change the very way we live. I put 3D printing additive manufacturing on this list. The two of these terms are synonymous in my mind, 3D printing and additive manufacturing. I'll explain that, why I say that in just a moment. The next slide, please. Yeah, we talk about rapid part manufacturing. Two main processes as far as it comes to part manufacturing. The first is what we all know, subtractive processes, where we start with a block of material and then we remove the unwanted material to shape the part. I mean, we all know about machining. There's one example of that, milling and other techniques for removing material. 3D printing is an additive process, where we start with an electronic design and then we add our wanted material to shape the part. And believe it or not, that makes a huge difference as to how you actually build parts. And I think I can show that to you in just a moment. If I may have the next, oh, there it is, it's right there. This will describe the steps that I will take in my talk tonight. First, I'll describe how and when 3D printing was conceived. Next, you'll witness how an additive manufacturing process can produce a part that is impossible to make using traditional manufacturing processes. And then following that, I'll show you how a major company has adopted additive manufacturing to produce a highly complex, high-value part in jet engines. And last but not least, I will give you one glimpse into the future. If I were 10 to 15 years younger, I would be printing homes in Armenia. And I'll talk about that in just a few moments. Stereolithography. The simplicity of this initial concept is most impressive. If your dentist ever hardened a filling using a light beam, you have experienced the basic concept of this revolutionary invention. My wife tells me that certain nail polish is set by exposing the polish to ultraviolet light. Maybe you women know about that. Chuck Hull is the inventor. He's now 79 years old. And Chuck was working at Ultraviolet Products Incorporated when he invented stereolithography in 1983. The company sold photosensitive liquid photopolymer inks that hardened when exposed to ultraviolet light. Stereolithography uses a beam of ultraviolet light to harden one cross-section of a part additively after another until all of the layers create the solid object. If I may have the next slide. You can see here how stereolithography works. You have a laser beam here, a scanner system that directs the laser beam so that it will print on the surface of a photopolymer what exactly is the construction of that layer. And then this whole vat will drop down so that another increment of photopolymer is there, and then you'll print the next layer on that. One layer after the other until you have built a complete solid product from that sequence of events. This next slide, every time I see it, my mind is blown. It's this impossible part that is, I say, impossible by making it using traditional processes. May I have the next slide? And now, all right, there's 91 tiny balls in this product. Here it is right here. And if you would just move that along, stop for a moment. You can see what kind of, there's some liquid plastic that's being deposited very rapidly, and you can see that it is being guided by electronic design of the part. And if you move it along a little faster, okay, there's the finished part. It has a substrate to it, so the gentleman will then remove that part from the substrate. If you move it along a little bit further. And now he's going to remove some of the unwanted material. Keep going, yeah. Go to 3.4, 3.5. All right, so he's loosening up some of these parts. Go a little further.
Pounder jack.
Okay, here we got it. Now look at that. That is amazing to me. I don't know if it's amazing to you, but that's made as one piece. All those parts together, all at one time, was produced as an additive process. Now that is remarkable in my mind, and that is what is going to change a lot in the future. It takes time for these things to happen, but they will happen. It's just a matter of time. If I may have the next slide. This is an example of a company that has the resources and the intellectual capability of understanding what the implications are of additive manufacturing, and they are applying it. Now, I just showed you the making of that part. That impossible part was made in plastic. They are using metal, and they're using that to produce parts for jet engines. If I can see the next slide. This is a nozzle, a fuel nozzle that's being made. There's 85,000 of these fuel nozzles will be made. If I could have the previous slide once more. Okay. This is for the GE engine 90. And they plan to produce 100,000 3D printed components into that engine. Not into the one engine, many engines. The fact that it's being made in metal is a huge advance because it's relatively simple to make things in plastic, mostly because of the temperature. Plastics melt at a relatively low temperature, close to room temperature. Metals, you have to get to thousands of degrees in order to be able to melt and to form in the shape that you are interested in doing. Next slide, please. Yes, Henry Ford is before our time, even before my time, most of our time. He's credited with the benefits that we've realized from mass production. What was the benefit of mass production? Because we could produce many, many parts, but they had to be standardized. And you got the benefit of low unit costs because of that, and we all realize low costs, much lower costs than if you had to make each part in a custom manner. The benefit of additive manufacturing is that you can change each part by just tweaking the electronic model of that part. And that has a huge implication. I don't know how many of you have ever heard of Invisalign. Have you heard of Invisalign? It's the thing that you put in your mouth in order to straighten your teeth. There is a company that last year was one of the most strongest performing stocks in the market that does use this technology, and they have built a plant in Mexico. I mean, I'm sure Donald Trump is not too happy about that, but they have a huge plant with many, many machines, and they are producing these parts by the thousands on a daily basis, and each one is different because each of us would have a different contour in our mouths in order to be able to use this technology. But you have the potential of having custom mass production using additive manufacturing. Now, I claim that the possibilities are limitless. When parts are made using computer-directed machines, labor costs are drastically reduced. Since the main justification for foreign labor is low labor costs, I predict that manufacturing will be returning to this country, but with much less labor than before. Now, 3D printing can be done in your own home once you decide that this is something that I don't think I'll see it in my day. This is why BERGE is thinking about things as they are today. I'm talking about things as they will be tomorrow. That's why I say how old you are will determine whether you realize the full benefit of this technology. But in the future, you may well be able to print your own clothing to fit your own size and shape. print your own shoes, print replacement parts, either at home, or if you go to Home Depot, they may have machines there that can do this. And electronic designs can be just moved overseas in a moment by electronic means, so that you can end up designing in this country, making in some other place, and having it shipped here. So these are all potentials that are coming along. I wanted to show this one slide. Here is a 3D printed home. One day, $10,000. Can you imagine? This is just how Nozzle just depositing the concrete in just using a thumb drive for the design. You just put it in the thumb drive and then it'll have any shape that you want. And it can be done very quickly. This is an ideal way of producing homes for people that now do not have a home. And believe it or not, there are many people throughout the world that do not have shelter. And I think this is an application that would be very effective in Armenia. There's parts of Armenia that can use this kind of technology. If I were 10 years younger, I would be printing homes in Armenia. I don't know, maybe someone here would be willing to consider that kind of an opportunity. I think there's a huge opportunity for that. But in any event, I do appreciate your affording me the opportunity to speak to you this evening. I'm old enough that I can speak as a historian. I'm also old enough to be a visionary. I've seen where we've been. I think I have a vision of where we are going, and I hope that we all live long enough to realize the benefits. Thank you so much.
So Jack, the good news is we 3D printed a time machine, and we've added 10 years to your life. All right? Is that cool? Okay. Well, we're going to get questions to Jack. I'm sure we have plenty of them, but we want to get through some speakers before we do. Our next speaker is AZIZBEKYAN, who is a scientific associate at the Institute of Physical Research. I'm not going to read his bio, but it's substantial. He earned his PhD at the University of Lorraine in 2012. He's a leading expert in 3D printing in Yerevan, Armenia. And last year, he helped develop a proof of concept and implemented 3D scanning and printing environment for custom technologies, customized technologies, a Canadian startup, which is focusing on commercial applications of 3D printing. So he'll tell us a bit more about what he's doing. HRAYR, are you ready to go? Do you need that too? Oh, you can't see behind you. That's right. You don't have eyes behind your back. I forgot.
Yep. So, hello. Thank you very much for visiting this event. And I'd like to thank also organizers of this event. So this is about Yerevan, Cambridge-Yerevan Sister City Association, and also to the hosts, Armenian Cultural Foundation. I find this place really nice, and the atmosphere here is very welcoming. So thank you very much for all you've done to make this possible. Just a second. Okay, so I don't know if you've noticed what's going on behind. So it's a famous mountain for Armenians. It's Ararat. Okay. Oh. Okay. Well, okay, let's then probably close this and just be here. So let's go forward. So my bio is a little bit introduced here. Actually, I don't think that there's sense to go deep into details. The more important thing here is that related to 3D printing is that we were able in Armenia to replicate and even optimize some processes that are made for creation of 3D technologies. So one of those is 3D scanning that you can see on the left. So this is 21 poles surrounding a full body, and it can in one shot, in quarter of a second, just shot you and create your 3D model just after one shot. So there are about 200 cameras installed. So this one is already done by Customized Technologies. So the next thing that we've done is patinating the sculptures. So you can see this sculpture here is also shown right on the table. You can later just see it and touch it, see how it looks. So this one is also done in Armenia. The other one, this beautiful orange, is actually you'd like probably to try. You can try it right there. It's also printed from paper. It's full color, very beautiful orange piece. And also what we have done in Armenia, it is just creating the environment for scanning and then printing and managing all these procedures by software. So all these steps were done already, and this is why we are here. So please, next one. So we had a nice introduction in 3D printing. Just to make refreshments, the 3D printing is a deposition of layer by layer of the material. So you can also just think about 3D printing as putting blocks of buildings. So it goes layer by layer, and you at the end you're having 3D printed house. Actually, before these times, it were done by labor force. Now machines can do the same things. The plus is here that you can do it much more smaller, and you can do it automatically, and you can do it additively. And one thing about additiveness is that you can keep this in your files, so you can restore and print it later on in 100 years. If you try to do the same thing with technologies that now exist, it means that by molding or just having some schemes by which you have to work, replicating it will take much longer times. Materials that are used for 3D printings are very different. It could be from plastic, powder, liquid resin, paper, metals, and even chocolate. So please show us a few next pictures. So this is the additive mechanism, and here you see a chocolate cup. So we tried to bring it here, but we were very, we need something to eat, so it didn't reach the point. And there are very different technologies that are used for printing. I don't know if there's a sense to pass them by, but there are, well, one on the left is just kind of putting the blocks together. The next one is kind of soldering with your solder. The next one is using the laser to actually put these blocks together from liquid. The other one is much faster way, just by projecting and burning the layer on the object. And the last one is powder printer. So please, next one. Yeah. Now I've listed here advantages of 3D printing. So the first thing is customization. It brings you freedom to make new design, impossible design, fascinating design, and designs that will blow some minds, you know. For example, this one is blowing my mind that it's printed just in the one on the left. It's printed in as a one object, and each gear here connected to others. So by just rotating once, you have all the system working here, right on the left. The next big advantage of 3D printing is fast prototyping. So it gives you the possibility to test your idea and do it faster, so you can try things and just see if you fail or not. For example, I have here some bottle. If you try to manufacture it by just usual ways, it means by creating moldering, by designing, it will take you a few weeks of design, and then if you fail, you have to start again. While here, it will take just a couple of hours to make this, and just save it for next times. Or if you want to change something, you don't need to start from beginning. You can just open the file and make your simple changes and print it again. So in this sense, I would agree with both of previous speakers. From one point of view, there is nothing new we can actually create. It is either good or bad, and it's a question if there's a bad or it's just absence of good. So in this sense, BERGE is right, but from the other hand, it will change our environment and the quality of life. So this actually change our quality of life. It's not new. You could do it probably 100 years ago, but now you just can do it quicker, faster, and you can create impossible shapes that probably will take very long time to have one, and practically impossible to create for tiny pieces, etc. The other big advantage is that it takes a small batch production. So you can, if you need to create just one, you don't need to just start your machine of creating this product to have different people on design, on moldering, on bringing metal. You just can design it very quickly and say to printer to print it. Okay, so if you are creating just one or just a few of these samples, then it's much better to use a 3D printer. But if you are making a lot of numbers, as it has been mentioned before, then you need to, actually it's more cost efficient to go to conventional technologies. So here you can see the graph when 3D printing is better, and if you have just big number of samples that you want to get, then you have to just pass through the line and go to manufacturing by usual means. So next one, please. Now, well, okay. So how it will help to Armenia? Does Armenia need to go through this process? Well, everybody should follow this, and sooner or later everybody will go to this, as previous speaker noted. But there are some problems that could be solved right now with these technologies. So let's just name few. So first of all, it is small market size of Armenia. It is a very tiny country. And the remedy for this is small batch production. So you just can have some printer and print whatever you need just for your needs. The other big problem for Armenia is a lack of natural resources. So if there are no resources, then you have to use your brain. So you have to be technologically competitive, and you have to use your human resources, and also you have to follow up on science and technological news to be in frontiers of developments, so that you can compensate the lack of natural resources. The other problem for Armenia is logistical dependencies in the region. So you know that it's surrounded by not so good neighbors, let's say. So there are two closed borders, and there are conflicts sometimes with or misunderstanding with others. So this problem is also can solve by local manufacturing. So if you can manufacture it here, you don't need to bring something from China or I don't know wherever else. The high import dependency is also could be solved partially by import substitution, and centralization of economy around Yerevan can also be solved because of 3D printing. Because you can go in a village, become a good designer of 3D models, have a printer, and just print whatever you need for your community, okay, or for your product. So those are good things about 3D printing that could be useful for Armenia, but of course there are some drawbacks. So for example, rapid technology change can cause your investment into technology become useless just a few hours or a few years later, because technology becomes quickly cheaper and much better time during the time. So the machines that were few millions just a few years ago, today they are about $100 or $200,000, and we expect them to become about 20 in a very, very, let's say, not very far perspective. Another problem here is conventional mindset. So in order to use these technologies, you have to think in 3D. So you have to understand how this 3D printing, what is it and how to use it instead of thinking in conventional way. Lack of technology awareness is also a problem because, well, everybody know that there is something something that's called 3D printing, but nobody really feels how it works and what it is. So that's why you are very welcome to just see what's there and what kind of models we have here. So there's also lack of legislative base. It means if you go now and print a house, who said that this house will be legal to produce and to sell? So probably tomorrow you will have problems. So such kind of things are also are necessary to consider. There is also lack of government proactiveness. So the people around the country, they have to understand what is it and why it is important for the country. And also it can endanger, the 3D printing can endanger a conventional labor market. It means the industries that you are working now could be replaced partially by or completely by 3D printing. That's again a shake for a society. So this has to be considered prior doing any kind of movements. But I guess this could be also a positive thing because you are having new type of labor that's much technological. So next one, please. Well, then the question: who said that it will be possible in Armenia? What gives you hope that it can work in Armenia? Well, there is some success stories that we have and had in past. So, for example, now our IT companies are rising quite good in Armenia. So there is one big union that unites all these IT companies, and there are very famous brands that are now locating to Yerevan, and some of brands even just move their headquarters to Yerevan. So this gives hope that it is possible to create this in this environment in Armenia. There's also quite nice initiatives in engineering. For example, this Yerevan Engineering Association unites about 20 companies working in engineering, and they collaborate very actively together to have to keep them in market, and they work in quite large area of the market. It's starting from Africa to India and Russia, and now even in Europe. So that's quite huge market, and this success story also supports the hope. Educational efforts are also being done in Armenia. So there is TUMO Center for Creative Technologies. Probably many of you have heard about this. This is a kind of model of future. So it supports a lot of K-12 students in being fascinated by technology and nowadays technologies, and one of their programs just is about 3D printing. IB schools are also implemented in Armenia. There are for now 3 IB schools, and this is also shows that Armenian educational system can be integrated in international society. So IB international bachelor schools are about 3,000 union of about 3,000 schools around the world. And it means this educational system also is competitive. There are also quite good initiatives in IB foundations. They have a school and they want to just implement a kind of model of IB bachelor. They have Formlabs, and also Armenia had quite nice achievements in Olympic excellence at K-12 students. Scientific is Well, we can say it's very productive in sense of given money to the number of papers that it generates. It's actually one of the best in the world, but because the given money are about zero. So if you just divide anything to zero, you know that you get enormous numbers. So, however, there are few institutions in Armenia that are quite successful in science. Namely, there is a huge union, but actually it is Academy of Sciences of Armenia. It unites about 33 institutions in all fields of science, so starting from hydroponics, going through biology, chemistry, physics, linguistics, etc. And some of those are quite competitive. There's also a huge center called YERFI, Yerevan Physical Institute, and there are some small ones that are rather new and they are much more effective, let's say, for small communities. So they are, for example, Yerevan N Square or Yerevan N. So overall there are about 50 institutions. So let's pass to next slide. Well, in 3D printing of those, you can see the institutions that work in education. So one of those is TUMO, the other one is ARMAT, that is again one of the famous ones run by UITE. There is also NGOs, Engineering, Yerevan State Engineering University, and also ANA Laboratory. So they all have some kind of implemented programs, bigger or smaller. There are also efforts in printing, so there are setups for printers in AUA, at Epic Laboratory, at Engineering University, at TUMO, Yerevan Engineering Association, at Grigol and Tech. But the development is being done just in 3 of those. So this is a printer, a DLP printer, very one that actually works like a Formlabs printer, except that it has touch screen that allows them to print more user-friendly, let's say, and just simple FDM printers at Instigate and Yerevan Engineering Association. There are less scanners than printers, so there is a scanner in AUA, American University of Armenia, Engineering University at TUMO, and there is one developed scanner in Armenia that I have showed you before. So, next one please. By rising 3D printing, it means you will take with you also a lot of other industries. Please step back. Yeah, a little more. Next, previous slide. This one. Yeah, thank you. So those are 3D scanning, 3D modeling, digital sculpting, software development, 3D printing, printed parts finishing, technical support, R&D of all these technologies. So there's a lot of work and a lot of labor, new labor that will be opened after rising this printing environment. Please, next one. Yeah, well, okay. So those are examples of these industries. Well, let's step forward. Thank you. So applications, what kind of applications and what kind of revolutions we have today in this industry. So dental industry, please click with it. So dental industry is revolutionized by just printing and simplifying changes in dental models. Jewelry is the next one, so it's already heavily used in jewelry preparations, so you can just change your models, you can take existing models and make modifications. There's also modeling of, for example, here you see 3D printed shoe that you can just take and that's it. Okay, you can print and modify the shape of your shoes as you want. There's also architectural revolution when you should not just bring your model into life by your hand, but you can print it instead. There's also construction revolution. You see a 3D printed house here that were also spoken before. So this is a real printed 3D house. I think it's really nice. I think only the glasses here are not printed. The rest is printed. And there's also medical application you can see in next picture. So can you just distinguish between these two ears? So they just look like the same. And not only this, but also biological parts, muscles are being 3D printed today. And also it's it changed the industry of engineering. So this is 3D printed car, purely 3D printed car. Okay, so I think that's nice. You can print your own car and you can modify it for your needs. So you can add something and etc. So you shouldn't be like the same as all the others. Next one, please. Now, well, so how this can be implemented here in Armenia? There are many different ways of implementation. We can just wait while everyone would have it, and it will come also to Armenia. This is the simplest way. But I think much more effective is to have a kind of success story. So if some kind of reactor will start to work, just to show what kind of novelties they are, so people will come and touch everything with their hands. So they will have metal printed materials, they will have true color printed materials, they will have just very fine arts and architectural. So this all has to be on the table for those people to come and see and be inspired. Or else they have to spend a lot of money by themselves to go to, I don't know, see it somewhere else. But that's unreal. Okay, so I think creation of success story is very important thing for this. And also it should be done together with community building. So you cannot do everything alone. You have to build community around it. You have to support people to work in this field. You have to spread information about this. And this event is actually one of these steps. Okay. So probably that's generally all I wanted to highlight today. Thank you for your attention. And if you have some questions, then later. Thank you. Yeah.
HRAYR, I know you have only recently come to the US. Have you been able to visit any of the 3D printing centers?
Yeah, today we've been at Formlabs. We had a nice presentation and show around. We saw quite nice printings, and I got one, the dental one. So yeah, it was nice.
So you had your teeth fixed, is that right?
Sorry?
You had your teeth fixed?
I hope to do it tomorrow.
Oh, okay, good.
Yeah, I'm keeping it in my pocket, you know.
All right, HRAYR, thank you very much for your presentation.
Thank you.
Since HRAYR visited Formlabs, I thought the next speaker I would invite is Jennifer Milne, who's product manager from Formlabs. Anybody here know where is Somerville? Where is it? It's right down the street, right? It's very close. And Jennifer has been with Formlabs how many years now?
Coming on for 6 years.
Oh man, you're getting old.
I know. I also feel like a historian.
Yeah, you are definitely a historian.
Yeah.
And you know, again, long bio. Coming out of MIT, Formlabs employs now 400 people across offices in Germany, Japan, and China, right?
And Somerville. Yeah.
Not to mention Somerville.
Not to mention Somerville.
Yes. And I'm glad it's not in Cambridge, it's in Somerville.
We were in Cambridge, but we moved to Somerville.
Actually, they moved the border between them so that you ended up in Somerville, is that right?
Pretty much.
Okay, cool. You can give your presentation.
All right, so I have a lot of slides, so I'm going to try and rattle through them. But yeah, this is a piece that was 3D printed on a Form 2. It's just one of my favorite pieces. It kind of shows you, I think when people think of 3D printing, we think about the engineering and the chunky parts with CAD design, but there's also design tools now that are very organic. So this is a digital sculpt, and it was made by an Austrian artist for a natural history museum. It's really cool. Yeah, next slide. This is me. I've been at Formlabs for 6 years, and why that's significant is Formlabs is only around 7 years old, so I was one of the early members of the Formlabs team. So yeah, I can talk about a lot of stuff. I will struggle to talk in 10 minutes, but I'll try and I'll just cut myself off if I go too long. Yeah, next slide. So this is our main product, the Form 2. I really appreciated the opening presentation because we talked about stereolithography, which is actually the first method of 3D printing that was invented by Chuck Hull in the 1980s. So what Formlabs did was actually take that technology, and we were the first people to offer it in an affordable desktop package. So we use stereolithography. So it's using light-sensitive resins, and we actually use a laser to draw the shape. So that's what hardens the material and builds it up. Yeah, next slide. It's $3,500. So that's what, when we say accessible, and I have another slide on this. Why this was significant is this is our original product, the Form 1, which was launched about, I don't know, six years ago or something now. And at the time, affordable 3D printers were the FDM kind, which is the extrusion-based one. So this is an example of Make magazine from, I think, 2013 to 2014. So when we came out, this was a totally different technology, and there was literally nothing like it on the market. So people that knew stereolithography were really excited. And if you go to the next slide. And at the same time, however, we were taking this professional technology and offering it in an affordable desktop product. So this is what industrial 3D printing looked like. These are like room-sized machines. They cost $100,000 plus. You needed a trained engineer to come with it, and they weren't really accessible at all. So next slide. So this is basically what Formlabs are really good at. So on the left, you have an extruded piece. You can see typically you get these lines and these surface details. So on these sort of cheaper 3D printed parts, you will feel the ridges of the way it was built up. This is a piece off a $300,000 SLA machine. The material cost was about $6. And what Formlabs came in was created this new space of high quality, affordable 3D printing. So our piece is pretty comparable to the high-end Rook, and material cost is about a third of that, and the machine cost is significantly lower, about 100 times cheaper. Next slide. This is summed up really well, and the Wohlers Report is a research report about the state of trends in 3D printing. So it says, Formlabs defies a classification that traditionally separated industrial systems to desktop 3D printers. Next slide. This is what I've been through. So the company today is 400 people. We've shipped over 35,000 3D printers in that time. That's absolutely more SLA 3D printers in the world than existed before Formlabs was created. Wanted to stress we're local, we're growing, we're hiring a lot. So if you or anyone you know is interested in 3D printing, I would definitely encourage them to check us out. Next slide. And generally, most companies who are making physical products use 3D printing today. So we work with big enterprises, we work with small independent startups, and 3D printing is being used in almost every product development area you can imagine. Next slide. This is Formlabs methodology. We make sort of professional style lithography accessible. And on the next slide. And the big announcement in June for us was that we're actually going to take the same model that's worked really well for us in stereolithography and apply it to another 3D printing technology. So Formlabs has announced they're actually working on an SLS machine. So this stands for selective laser sintering. And again, these machines cost hundreds of thousands of dollars. We've announced that we're creating a product for $10,000. So while this is more expensive, I wouldn't say this is in the everyday accessible range in terms of what this means for industries or companies that are already using this technology. It's making it a heck of a lot more accessible than it was before. Next slide. So I will talk a little bit about this technology because it hasn't come up yet. So SLS also uses lasers, but it uses high power lasers. So the material you're printing with is a powdered nylon. This is similar to the process that's also used in metal printing. And then you drag across a layer of powder, and then you're actually heating it up to just below melting temperature. And then it's a high power laser that you're using to draw the shape that's actually melting the powder and fusing it together. And then that moves down, you drag across a new layer of powder, and you draw the next shape. So when SLA, the original technology we showed, is particularly well known for beautiful surface finish of parts, so it's used in a lot of looks-like prototyping or presentation models. Why people like SLS is that you're actually printing with nylon, which is an incredibly strong material. So this is used a lot by engineering or in aerospace or in the military, like these kind of industries where you need strong functional parts that are going into as used parts on machinery or for more end-use scenarios. Next slide. This is a range of parts just to cover some of the more like, this lobster was our example of a kind of impossible piece. It was printed in one go with articulated joints designed by one of our designers. And the other thing about nylon is it's both strong and pretty flexible. So the headphones, for example, have a nice give to them. And the bike pedals are functional. All this stuff's been in use for some time. Next slide. The things I want to talk about in terms of the future of 3D printing that I'm particularly excited about are materials development. There's a lot going on in new materials, and that breeds to opening up new applications. So we've talked a lot about applications, and generally that phrase is just like, where is 3D printing being used in meaningful ways and in new industries? And sometimes by just offering a new material, we open up a whole new product category. So dental already came up. It was about 2 years ago, Formlabs announced our first biocompatible resin that was developed for the dental market. And now dental is a huge market segment for us. So while we have a great platform, the Form 2 is kind of this great, easy to use desktop 3D printer. It's kind of materials that are driving a lot of the growth into new industries for us. So next slide. So dental, I guess I can talk about that a little bit more just to elaborate. There's a number of different materials. These are some of the ways 3D printing is used in dental. Our first material is for surgical guides. So in the past, the dentist would, if you were getting a tooth inserted, if you had a gap or you lost a tooth, typically they would kind of like look in your mouth. They might take an impression with a rubber or something that they then look at, and then they basically would drill a hole and pop in your new tooth. Nowadays, you'll go in, they might use an oral scanner. It's much cleaner, it's much faster, and there's very accurate software that will spit out a 3D model for them. They print that, and then that goes over your teeth, and there's a little drill sleeve so they can go in and make a really accurate surgery for you. And then we're working on everything from models. Thermoformed aligners came up with Invisalign. That's what they're doing. We also do that in a much more affordable way than it's been done before. And we're actually working on 3D printed dentures as well. So it's a very new thing in terms of like, it exists, but in terms of getting the materials like strong enough that they're actually going to withstand like being used as teeth, that's kind of a new dental application that's emerging. Engineering is the biggest market traditionally for 3D printing. The main use case is rapid prototyping. As we talked about, anyone developing a new product is going to go through this iteration cycle, and now they'll make a lot of models in-house. But as the materials get better, we also get into this sort of small batch manufacturing, which has come up previously. So if the materials are good enough to be used as end-use parts, then 3D printing is actually a meaningful way to actually manufacture the parts, not just prototype them. So this is an example of Pankel Racing Systems, who are in Europe. I don't remember the exact country they're in, but they make custom gearboxes and for like Formula racing teams, and each gearbox they manufacture on their line is different, and these are just 3D printed jigs that they use to hold the different parts of that component while they're assembling it. And they've printed like thousands of these, and it saved them hundreds of thousands of dollars. That's not actually the thing they care about, though. What they care about is the time saving, in that they were able to deliver on this demanding client job, because previously they would have had to send out for these to be machined in metal. So that's another thing we're really interested in, is educating people. I think there's a lot of manufacturing where the tooling and everything is made in metal, and those companies are interested in 3D printing metal because that's where their mind's at, and we're kind of like, does it need to be in metal? What other material requirements would you consider plastics? Because this stuff's much more affordable, and a lot of the times it is like capable. You don't need to machine stuff out of metal. So we won't mention the sort of paradigm shift of not just wanting to do things exactly as they were done, but rethinking them for 3D printing. Next slide. And yeah, I thought for this audience as well, education is a huge market for us, definitely research students in every discipline imaginary. So millifluidics is a really interesting use case. So this is we have this clear transparent material. You can 3D print internal channels. So with our technology, these are watertight parts. So a lot of like lab on the chip stuff. I was talking to someone today who's using this in the energy field. And medical models for education is a huge part in people's training. Sometimes there's a school in Germany and they're doing aneurysm surgeries, and the students don't meet a real aneurysm until they've passed all their training and they're faced with a patient. So how can we improve their education to give them much more lifelike models as they go through that they can actually interact with and do practice surgery on? Is understandably incredibly beneficial. So we have a lot going on there. Next slide. And then to materials, this is some of the more cutting edge stuff. A lot of research projects in 3D printed materials, everyone's excited about filled materials. So the notion of this is with the resin-based printing, how can you load it with nanoparticles to make them even more interesting materials? So Formlabs has a couple of materials on the market now that do have fillers in them. One that we've announced is a ceramic material. So this is a resin that is loaded with ceramic powder. It's about 50% loaded with ceramic powder. So the part on the left is the printed part. Then you fire it and you're basically burning out the polymer. And during that, the part is sintering, and then you're left with a fully ceramic piece. So that's one reason why filled materials are interesting, because you can kind of move away from plastics. And so you see the shrinkage that happens there is due to that burnout process. There's a pretty significant amount of polymer. But why this is an interesting technical challenge is when you're loading something with filler, it's going to get more viscous. It gets much harder to print with. So particularly on our system, which is very broad and user-friendly, and it works with all kinds of materials, we need it to be quite low viscosity, because traditionally ceramic paste 3D printing exists, but typically these are 3D printers designed specifically for that. So they're printing really heavily loaded paste. They're about 90% filled, and they like scrape it across the platform. It prints apart, scrape it across again. So we're really excited about this because most people don't have access to ceramic 3D printing. I would guess there's maybe like 100 machines in the world that exist. Most of them are coming out of research universities. So we're going to be the first people to kind of offer a ceramic SLA material. Very cutting edge. Not sure what people are going to do with it. It's like we don't really know the applications yet. But I think a lot of people are really excited to experiment with it. So this is actually a cup designed from Nervous System that are also a digital design studio based in Somerville. And then on the right is our rigid resin, which is another example of a filled material. This is actually a glass filled material. Why putting silica particles in resins is interesting is you obviously get interesting thermal properties, and the parts are much stronger and stiffer. So for plastics, depending on their properties, they might kind of deform over time. So putting glass filled like reinforces them and helps them hold their shape. So again, moving to more functional parts. Next slide. So I lead applications engineering. This is where we spend a lot of our time, is trying to educate people. You know, we've already mentioned you need to kind of think outside the box a little bit. So we spend a lot of time there trying to help people figure out where they could use 3D printing. So designing jigs and fixtures is one. This is an example of a jewelry piece where you can actually print a mold to make a rubber mold if you want to make hundreds of parts. And we've also done some 3D printing of injection molds. Next slide. This is a 3D printed injection mold to make a small ball socket joint for a posable statue that someone had done. So this is huge. If you know anything about injection molding, that's how most plastic parts are created, and you're typically going to pay upwards of $3,000 for a tool, depending on the size of it, and it can go up to $60,000. So the issue is that when you're developing a product, that becomes a really hard stop, where once you pay for the tool, you can't really change your product. So now with 3D printing, even if this only works for a few hundred parts, you can still now prototype your tooling, which helps, again, product development companies stay really agile. And that's a pretty big paradigm shift in how products are developed. Or we have examples of, we have a robotics company in Cambridge who just wanted to make 10 parts for product testing, and they were able to do that with 3D printed tooling. And that part is under $10 worth of material, so it's really cool. One more slide. And this next one, these are some medical examples. This is another Cambridge-based company, Biomedical Modeling Inc. So they made a 2-part mold to actually inject it with silicon, and that's to simulate a child's spine, to practice surgery on a spina bifida, I think it was. And this is the robotics company I mentioned. This was, again, a 2-part mold that they used to inject actually do overmolding. So this is a robotic gripper finger. There's electronics in there, and they actually shot over it again with a soft, flexible surface. So the reason I like to talk about molding is I do think when people think of 3D printing, they often they think of limitations with the materials, but depending on your approach, you can use 3D printing to create parts in all kinds of materials. I think if you're making a product, there is always a way 3D printing can help, but it kind of depends how you approach it. So I think that's everything I had, other than a question slide. Oh, this is one last one, which is new for us, which I think is really cool. Someone on my team worked on this. Developing custom fit earphones. That's another mass customization example. Currently, these exist. It's pretty expensive. You're probably going to pay like $200 for a set of custom fit earphones. And we worked with this company who had this great process. Fortunately, they're comfortable sharing it, which is what we like to do to show people what's possible. So here they printed a thin-walled mold. You inject it with silicon, and then we call it a sacrificial mold because you basically just break that off, and then you have the silicon earphone. This is a process where anyone can do it with a $3,500 machine. And that's super exciting. And you can see how, we're really focused on how do we bring mass customization down the food chain into this much more accessible space. So this is something that a small audiologist could offer now as a service in their shop, rather than currently what happens is you can order these through your audiologist, but they will send away to a company that makes them and send them back. So there's a lot of premiums getting rolled in there. Mass customization is basically how 3D printing can be used to create products that are going to fit on your body. So that's where eyewear, audiology, shoes have come up, medical devices, dental, all of this makes huge sense for 3D printing. So I think that's my last slide.
Very good.
Thank you.
Thank you very much for your presentation.
Thank you. Yeah.
Cool.
That's the way.
Appreciate the introduction. My name's PEREZ. I'm the founder of a company called NVBOTS, which was an MIT 3D printing spinoff, originally started in 2013, 2014 timeframe. I recently exited that business and sold it to Cincinnati Incorporated, so that's why you see their branding, but kind of the mixed name of the NVBOTS business unit, which is what I'm running for Cincinnati. Next slide. So, give you a quick introduction to Cincinnati. Founded in 1898, old manufacturing company. We make industrial manufacturing equipment that lasts a long time. On the bottom left, you see an industrial laser cutter. It's used to cut sheet metal and thick sheet stock. Typically used in automotive and aerospace types of applications. And in the top right, you see a press brake tool, which is used for bending sheet metal, which you'll see used in automotive production, again, aerospace production, large scale. These are both machines that would barely fit inside of this room. And this one wouldn't because these ceilings aren't tall enough. Just to give you a sense of size here. You don't see it on the screen. Next slide. So at Cincinnati, we have, I'm going to stand a little bit back because I'm getting a little feedback. We have two different 3D printing technologies. One's called BAM, the other one's called SAM. BAM stands for Big Area Additive Manufacturing, and SAM is Small Area Additive Manufacturing. The BAM prints a little over 80 pounds an hour, depending on the material that you're working with. To put that in context, you can 3D print a car chassis in less than a day, like a full-size car chassis at that type of feed rate. That machine's also about 40,000 pounds. I think maybe two of them could fit in this room, but you couldn't get it in here because the windows aren't big enough. Okay, just to give you a sense of the scale of these things. And then the BAM has a little brother, little sister, however you want to think about it, called the SAM, which is a small footprint. Prints at a much slower rate, but it's also a machine that is significantly smaller. This is something you could carry around yourself or with a friend. And it has a feature that's unique in the market you won't see on any other 3D printer, which is auto part ejection. Next slide. So I just want to make it visual. That's the SAM in the front, and the thing blocking the entire background, that's the BAM. Just to give you the contrast here. I like this as a story for customers that are interested in doing things at a large scale in 3D printing, because if you're going to do something on a BAM and you're going to fail one time, you justify the cost of buying a SAM to start with. And the interesting thing that we've discovered is if it's going to fail geometrically printing at the large scale, it will fail at the small scale first. So these products work very nicely together. Next slide, please. All right, talking about construction and potential uses of 3D printing. I personally don't think people want houses that have rippled edges, and 3D printed houses are that, rippled edges. I think where 3D printing really fits into construction is in creating custom molds for more unique geometries to cast concrete into. What you're looking at is kind of a twisted archway that would be really, really difficult to do with normal 2x4s, but we 3D printed the mold so it was really easy to do. Next slide. This is a really cool example of a BAM tool. We actually set the Guinness Book of World Records for the world's largest 3D printed part. This is used to stamp Boeing aircraft wings. So your airplane is made using a 3D printed tool to actually make the wing, you know, the thing that we're all relying on to not fall out of the sky. Next slide. Two more examples of really awesome tooling. On the left, that's a turbine blade for a GE wind turbine. On the right, this is a 35-foot long boat hull to cast fiberglass into. Next slide. This thing actually weighs about 50,000 pounds. Yeah, just really big. Next slide. Oh, yeah, okay, cool. For everyone that's kind of more on the artsy side, I'm a mechanical engineer by training, but this actually caught my eye. This was at the Design Miami, I think it is. It's an art installation that somebody put up, and I think it's kind of a gazebo type of more organic gazebo, and I really like it. I think it's a beautiful piece of architecture. Next. So I've got a couple of videos coming up to actually show the printing of these. On the left, that's a carbon fiber composite chair that we 3D printed. Really simple geometry. It's actually printed flat on its side and it just comes straight out. And you can make it contour to your body. So you could actually make a completely custom chair. If you have a crooked back, straighten yourself up, right? Whatever the application is. And then here, this is one of the first 3D printed cars. I think the professor had a picture of a 3D printed car in his presentation. The company that does a lot of that is Local Motors, and they actually rely on Cincinnati equipment to produce those cars. Next slide. So this is one of the first videos ever. This was at about a 10 to 15 pound per hour rate. So we're now significantly faster than that. This is just the tool path that it follows to print that chair geometry. It's really simple. You just print it like a snake and print it up and then turn the chair upside down, and now it's a functioning chair. All right, this is a really cool video. Let this one play. This is a time lapse, so it's sped up. This is not real speed of the car being 3D printed. You can see that instead of it being completely solid, has a honeycomb type of shape on the inside. That's so that we can make it lighter weight, but still have the same functional stiffness that it would, comparable to it being solid.
What's the material?
That is an ABS carbon fiber composite. It's about 20% chopped carbon fiber. Next slide. I was just going to keep starting that video over. So this is a slightly different car. Does anyone recognize what car this is? Ah, there we go. That's a car enthusiast right there. Next slide. This is it's a Shelby Cobra GT500. It's a throwback to a 1960s era Shelby Cobra. That's to give you a sense of the scale, right? Like these machines are huge next to this machine, next to this car. We originally started out printing these parts, and then with a subtractive mindset, which was silly, we'd print them a little bit bigger than they were supposed to be and then shave stuff away. And we said, that's stupid. So we print them a little smaller than they're supposed to be, and then we kind of rub a surface filling material onto it to give it that nice solid surface on the outside to eliminate any ridges that you get at that scale when you're printing. Next slide. Barack Obama and Joe Biden actually enjoyed taking a look at this car. This was very near the end of their presidency. I think it was like 2015 when we came up with this car in partnership with Oak Ridge. Next slide, if you would. We've done a bit of defense work as well. This is a Jeep that was 3D printed in partnership with Oak Ridge National Labs. And this next video is really, really cool. We're only going to play the first 30, 35 seconds of it. That's a 3D printed submarine. Printed that for the US Navy. That's a carbon fiber composite submarine. The typical supply chain for a submarine is 270 days. And from idea to actually having a fully functioning 3D printed submarine, we did it in 30 days. Right? That's a huge improvement. And more importantly, I don't know if you guys know much about submarine naval technology. There's no metal in that thing. Sonar, it looks like a piece of wood to sonar floating in the water. It's a completely stealth submarine, which is really impressive. All right, next slide, please. Now I'm going to shift gears away from the BAM and tell you guys a little bit more about the SAM. SAM and BAM are both extrusion technologies. The BAM uses pellets as the raw feedstock. The SAM uses filaments, which in order to make filament, you start with pellets and turn it into a filament. So what you're looking at is a time lapse of a part being printed, and then that's one of our key patented features. When that job is done, it gets automatically ejected into the bin and starts the next one. Like your paper printer does page after page after page after page. The dirty little secret of 3D printing is that it requires human labor after every single print job. There's some people that are starting to add robotics to it. We were the leaders in this industry, and now folks are adding your typical robot arm to go in and take your build plate out and put in a new build plate. So people are starting to address this, but this is what enables you to print part after part after part after part like you're used to when you print 50 pages on a paper printer. Imagine going to a paper printer and having to remove each sheet of paper before it could do the next one. Who would print 4 copies? Does anyone want to print all the flyers for tonight if you have to go there and manually do it? Think of what that does to cost. This is a really big innovation for driving costs down, because as much as 3D printing eliminates a lot of labor in manufacturing, there's still a lot of labor involved in running 3D printers. Even as we make them easier and easier, you still need somebody there, and that at the end of the day is cost. That costs somebody something. And these machines are designed to run unattended. All right, next slide. Just wanted to show you a cool application in the tooling space, a precision tooling application using a 3D printed fixture for quick measurements. So historically, we measured these components on a coordinate measuring machine, but we would fixture them by hand. And it would take like 3 to 5 minutes to fixture each one. And then we created a flexural snap fit fixture that allows us to do it in less than 15 seconds and get a much higher repeatable result in terms of the angle of fixturing. So it's in the right place. And this allows us to measure the parts very accurately for quality control purposes. All right, with that was the end of my presentation. I appreciate you guys bearing with me and getting through it with me. I had some really fun, exciting pictures and videos, and I'm happy to answer any of your questions you have when it comes time for the panel. Thank you.
So we're going to switch gears a little bit. Up till now, we've been talking about companies that supply equipment for 3D printing. Adam, you're on a little bit in a different end of that food chain, right?
Correct.
So you use some of these technologies and you apply them in an area that you think of as education.
Correct.
Right?
Yes.
And maybe you'll expand on how your company, which is, by the way, Einstein Workshop, takes 3D printing into the education sector.
Right, and actually it's a little interesting because we've been talking a lot about how 3D printers are the wave of the future, but we're going to shift gears just a little bit. So next slide. My name is Adam Green. I'm an operations manager at Einstein's Workshop. Next slide. So at Einstein's Workshop, we teach kids kindergarten to 8th grade. So we teach STEM. A lot of people know the term STEM now: science, technology, engineering, and math. And we basically operate on kind of 4 pillars. So we do coding, robotics, game learning, and the big thing we're going to be talking about today, which is making and inventing, and involves 3D printing. So this is our 3D printer station. We run 3 PrinterBot Simple metals, and we do a lot of printing. As you can tell, we're pretty prolific with a very young age group. Typically, we start teaching kids how to do 3D modeling at about 4th grade. Last summer, we did summer camp. We did over 500 prints in 3 months, which is quite impressive for young kids. Whenever a kid takes a class with us, they get to print 3 times. So over the course of a class, a 4th grader will print 3 of their own designs, which is really cool. Next slide. But what I'm here to talk to you a little bit about today is, as far as teaching kids, before you get to the whole kind of 3D printing thing, it's important to keep in mind that to us, a 3D printer is more of a tool. It's more like a table saw than it is an appliance. We've seen some amazing presentations from some awesome printers which are getting closer and closer to being able to kind of just push and print. But there is typically some part of 3D printing where you have to kind of know what you're doing. The printers are going to need some maintenance. You're going to need somebody who has the skill and experience to teach kids how to do this. So it's important to support your program in that way. Next slide. So I'm going to do, that's my title. I'm going to do a little something different. I'm going to talk about, I can tell you a little story, which I wasn't sure this would be a good idea, but I actually just talked to a woman yesterday who is an educator at a school, and she was telling me about these 3D printers that were just sitting gathering dust and not being used. And these are stories that I hear all the time from educators. And so I'm going to tell you a little bit about the story that I hear and hopefully help any of you who decide you would like to try and bring 3D printing into an education sphere, how to avoid some of those pitfalls. So it usually starts with an administrator or teacher. They're online, or they're talking to some friends and family, and they hear about this 3D printing thing, and they think, oh, that's really cool. And they do a little research online, and they say, aha, actually, it's interesting. 3D printers are coming down in price. You can get pretty inexpensive printers now. The software is generally free, and the filament, the material you print out of, is pretty cheap. So they think, we can do this. We can do this in the school. So they go and tell their colleagues, and everyone says, yeah, this is such a great idea. We're going to do 3D printing, and it's going to be great. It's going to be great for the kids. It's going to be great for the school. So typically, they'll write a little grant. Actually, go back. So typically, they'll write a little grant, or worse, they'll actually go ahead and they'll actually like try and put it into the budget somewhere else, and they'll typically just go for like a few $1,000s, right? They'll buy a 3D printer, the 3D printer shows up, and now you look at your colleagues and you say, all right, who's going to teach this 3D printing thing? It's really cool, everyone's doing it, and you'll get a sea of blank faces. So you'll think, oh, Jordan, he's really good. He's smart, young teacher, knows all about tech, really good on his cell phone. I mean, this guy's like young and hip, he knows what he's doing. So you go and ask him, would you be willing to teach this 3D printing thing? Next slide. And his response is basically going to be, are you serious? Do you know how much time I have? I work 50 hours a week between teaching, and I have to write curriculum and grade papers. And by the way, I have my own family, and my basement needs to be painted. And did you know that I also already coach the soccer team and I do math league? And this is the story we hear all over the place. I don't know about other places, but in America, most teachers are already overworked. They're already overstressed. They're doing plenty enough. So what's going to happen is you're going to go around the school and you're going to find the one person that you think is going to be the best fit. It's typically this person, the librarian. All these dusty old books, this is a great place to do some innovation. You know, kids are already on their iPads. Let's go ahead and put it with the librarian. They're just kind of hanging out anyway. We'll give it to them. And that's typically the story. Happens a lot anyway. Next slide. So my first thing is, please, if you do this, make sure you budget for an instructor. Okay. You might need to hire one. You might want to hire somebody who does STEM in general. That's fine. Or you need to find a teacher who you know has the time and the energy, and they're budgeted to put some time into this so that they can learn the printer and learn the software and all these things. So that's number one. So let's go back to, keep going forward. But we're going to go back to that librarian, because now they're trying to figure out what's going on with this 3D printer thing. They're online trying to figure out how to design models and run the printer and set it up and supports and all these different settings and everything. And then the boss comes along and says, hey, I told the superintendent about this really cool 3D printer we got. You got it running yet? And they'll panic and they'll realize through their research that, oh, actually, I can just go on Thingiverse or one of these other websites. There are lots of websites out there where you can upload your designs. There's thousands, last time I checked, maybe millions now of models. So you can just go on and download these models and print them out. They're going to do that because you got to do something, right? Next slide. And then the kids get all excited and they start clamoring and they're watching it print and they're so excited. And you print this one little thing after 2 hours and all the kids are like, can I take that home? Can I take that home? And you're like, no, you probably shouldn't, but Billy, he's really cute, so you give him the print, but then all the other kids are really sad. So you start printing more and more and more, and you just print all these models. They're just going home, they're going online, they're bringing it in, they're saying print this, you print it, they take it home, and at the end of the day, the printer just sits. Once you're done, every kid's taken home a little tchotchke, they haven't learned anything, and they're bored, they're done. So almost, this is a slight caveat, you should almost never print pre-made models. It's a slippery slope, happens quickly, it's a bit of an addiction. Once the kids realize how easy it is to just go online and grab something, and by the way, if you go online, people design all kinds of things. They might not even be printable. They could have they might be designed to be printed this big, and you're trying to print it this big, and it's not gonna work. So good to stay away from that, and then we'll move on. Next slide. And there's the other problem, right? So let's say you do have a successful program and you're printing a ton, you're printing all the time, eventually your printer's gonna break. You printed a ton. Now, next slide, we can just kind of move through this one. So please budget for time to maintain and repair the printers, okay? Now this, a little bit of preventative maintenance can go a really long way. Anyone who runs 3D printers can tell you, you don't need a lot, especially, and I'm mostly talking about the less expensive models because that's typically what schools are getting. They're getting printers in the like few hundred to maybe $1,000 range, unless they get some really nice grants, which again, I'm encouraging funding to get good printers. Just a little bit of TLC will really make a printer go a really long way, but they have to know how to do it. So these are my cardinal rules. Make sure you support the program, both in time and budget. And then the second part we're going to get into right now, which is the education part for kids, is to focus on the modeling. We've been talking a lot about the printing aspect of this and how all these advancements and all the cool stuff you can do with the printer, but the printer doesn't do anything unless you model something. And that's where I think the opportunity for, especially young kids, as they get older, engineers, they can do all kinds of cool stuff. But let's start with some 3D modeling. There's a ton of software out there. There's a lot of free software, paid software. There's software for adults, high schoolers, but I'm gonna talk about two for young kids. Good place to start. One's called Tinkercad and one's called BlocksCAD. Next slide. So Tinkercad, developed by MIT, now owned by Autodesk. Really awesome piece of software. It's a drag and drop software. As you can see, you have shapes on the side. Kids can drag shapes over. They size them, they place them, they can make holes. By the way, both of these softwares are free and online to use. You can go home right now and go try some Tinkercad. Very cool software. Next slide. I'm a little biased though, because BlocksCAD is a software that we developed at Einstein's workshop. And the reason we developed it is because we wanted to give kids a way to create really great models, but to also learn a little bit more than they would be if they were just dragging and dropping shapes and just creating sometimes kind of a blob, right? So in ours, you're actually writing code to create these models. You're dragging out different shapes and you're adding code to translate. And some kids have done stuff like this with a program called Scratch, where they're learning coding. So they're gonna learn coding, they're gonna learn operators, they're gonna learn all kinds of cool stuff. So you can kind of just click through the next ones. And this is just to show you that as they're going through and they're going to be learning operators and loops, and they're going to be creating and drawing on their imagination, and stop there for a second, and they're going to create these amazing structures. And now they've created something that's worth printing, right? And now you're going to print this, you're going to be proud, they're going to be proud, and you've got this kind of amazing thing that you've worked on to get this result. Next slide. And don't worry, because they will grow, they'll get better, and they'll, click again, they'll develop into the technology. They will start experimenting with the different ways you can use this technology. They'll start to learn. The printer will come, all of that cool technology will come, but the experience of the modeling is what's really going to generate some amazing innovation on the part of the children. There's a kid who put some Lego wheels onto a car, which was really neat. This was from an innovation class where the kids were trying to think of how to help disabled dogs. And our printer station again. So, thank you.
Adam, thank you. Let's hear what you have to say, Chris. Chris is a program manager at Microsoft Garage Makerspace. And in fact, in Armenia, we have a Microsoft Innovation Center.
Oh, great.
And we are just starting to get Microsoft to innovate around 3D printing there. So
Awesome.
We're looking forward to hearing what you have to say.
Okay, great. Well, thanks everyone coming out. Thanks for having me. My name is Chris. I do work at Microsoft in Cambridge. It's a relatively recent job for me. So I'm going to talk about a little bit about my personal experience getting into 3D printing and why Microsoft is interested in 3D printing, and specifically why it set up a facility here in Cambridge. It's probably not what you expect. Our guests here have talked a lot about the technology behind 3D printing and the new technologies coming on 3D printing. I host an internal makerspace for our employees. So here in Cambridge, we have 400 employees who write software, everything from the Office program to Skype to other things that Microsoft provides. And so my job is to run a space called The Garage. And The Garage is an internal makerspace, so similar to Einstein's workshop, but we're not catering to kids, we're catering to our developers. So we have 400 developers who sit at a computer all day and they write code. And sometimes that gets boring. I shouldn't say that, but sometimes they need a break from that. And sometimes they want something different. And so what we've provided is we have a laboratory called The Garage where we have low-cost 3D printers and low-cost laser cutters and other low-cost digital fabrication tools that allow our employees to come down and experiment. And so what that does is, A, it can provide them what they think is a break from their day, but it also provides them with the white space where they can explore these new technologies and maybe land on what the next thing is. And so all these great technologies that we've talked about, SLA and SLS and these $100,000 machines, I grant you Microsoft has those machines, and those are making your next, laptop and things like that. These products that are coming out that are truly amazing. But what my role is, and what the reason we have low-cost 3D printing, is that we're very interested in how 3D printing and design for 3D printing can really change the design and prototyping experience. And so what I mean by that is by having low-cost 3D printing, there isn't a single person who kind of owns that technology because it's only a high-priced machine. Anyone at our facility has access to the 3D printers. And so you have one team member coming down who works on the Office team during the day, and then you have one team who comes down on the Skype and they start interacting. And now they have this common language they can speak. They can talk about 3D design. And they might do that to build something that they want, just for themselves to take home. Or it gets really interesting when they start thinking about, well, maybe I'm working on software, but maybe there's a hardware component that we could add to our software. Skype needs a microphone, or, whatever it may be, so they can add that hardware. And so as I can say from the standpoint, there's that benefit from kind of intellectual curiosity, but as computing moves beyond just the laptop, all of us have smartphones in our pocket. And I'm surprised at how many people have adopted Alexa or the smart speakers. These are really computers in different shapes and sizes. And so 3D printing might give us that capacity to say, what's that next computing device? And maybe it's a software engineer who now, because they have that connection to hardware, could come up with that device. And so I think the challenge as we move forward, that I'm most interested in continuing lowering that cost of 3D printing and that barrier to entry, so that the same number of people who can go on today and they can make a YouTube video, those same number of people are engineers now and designers and part of that development experience. That I think is really the revolution, or how 3D printing kind of revolutionizes things, is that you get everyone involved in that conversation about how we design things and create things, so that when we say, hey, we're doing mass customization, it's not one person defining what's custom for you. you're the one who's taking control and saying, this is what I want to make custom, and you're showing that design to people. So that's what I'd say. It's kind of taking these ideas to the next step. So I'm excited to be I've done 3D printing in my career, and I'm excited with that low cost entry, and I'm excited to be working at a new job and also launching this new facility in Cambridge where we're launching, a space where employees can come in. And I should note this is our 7th garage space that we've opened up worldwide. And what I'm most interested about as we continue to say we're democratizing 3D printing is that the garage space in Cambridge is kind of an experiment. It's on the first floor of our office building, which for the last 10 years has been open to the public for lectures in our conference centers. So we're going to experiment and say, well, what do we do beyond our 400 employees? How can we invite the community in and say, what do they have to add to this innovation process? And so we're still working out how we will do that and how that community piece will work. But I'm looking forward to making that happen. So thank you.
Stay right there, would you please? I'm asking the rest of our panel to rejoin you at the table.
Oh,
Jack,
okay.
that means you too. Jack. So, Chris, before you sit down, go back over there. What did you do before you worked for Microsoft?
Specifically, before I did a public art piece for in downtown Boston, so that revolved around 3D printing, and so. The Greenway Conservancy in the center of Boston, every year they choose an artist to do the rendition of the Chinese New Year. And so in 2017, it was the year of the rooster. And so I produced an art installation that was a kiosk that had a 3D printer in it. And over the course of the year, I produced 2017 red roosters that were knocked off and then given away for free.
Cool.
And so that was part of this continuing trend of democratizing 3D printing. I really like the idea of exposing someone in a public park to the idea that every 3 hours they could go by and maybe have a chance to get a 3D printed object.
And are you familiar with the Armenian Heritage Park in the Greenway?
Yes, and the changing sculpture.
Yep.
It's beautiful.
And we didn't 3D print that.
That,
although we
no.
would have liked to. If we had one of your big mother machines, what is it called? Bam Bam? Bam Bam? So let's start with some questions. Jack?
On a global basis, how advanced are U.S. companies compared to companies in other countries as far as 3D printing goes?
Very simply stated that the United States is the innovator, it was the founder, and it is still, I'm sure, the leader. It's interesting that I had lectured in China. I went there 3 times at the invitation of a professor, and I'm now called the grandfather of 3D printing in China. But I think they're still following us. Many countries have learned from the United States. Would you agree?
I would put Germany right there, unfortunately. We need to maintain the dominance that we had in inventing these technologies, but over the last 15 years, they're the ones who have pushed the majority of the innovations in the metal space.
Yeah, I would just also second that there's a lot of new technologies coming out of Europe as well, not just Germany. I mean, certainly in the ceramic space that we're getting into, there's a lot of companies coming out of Germany and born out of other European research institutes that are there commercializing the technologies. And like Ultimaker is another pretty significant company that's also coming out of Europe that has sort of taken over the affordable desktop FDM space.
I was wondering, there's a big contrast between BAM and very available, accessible technologies. Who's leading in bringing down the cost and making it democratized? China.
Making it cheap.
Cool.
As far as kind of the low-cost market, I think a big part of the history of the low-cost market was when the FDM print technology that was invented in the United States, commercialized by a company called Stratasys, their patents expired. And so part of the reason we had this large boom of desktop 3D printing is due to a project that actually was an Irish project at a university, where they wanted, when the patents expired, to this kind of hot glue gun extrusion technique, they created a 3D printer. And what they did that was very important was they didn't just create a 3D printer, they created a 3D printer with the goal of creating another 3D printer with itself. And so they did something which was they released those plans open and free to the public. And so that galvanized hobbyists and other people to start building low-cost 3D printers. And it was another American company who said, oh, maybe we could commercialize this technology again for the second time, that kind of ran with that and started. And so it was kind of, one could argue that 3D printing, which has been around for 30 years now, 40 at this point, it was the larger companies didn't see this low cost market as necessary. They were selling $100,000 machines, and it was only when their patents expired that other entrepreneurs came in and said, no, we can do this and kind of spread this to the masses. So I think there's a lot we owe to that first group who decided to say, we're gonna build this, but we're also gonna release it and let others have the same technology.
Cool. Hold on to that. Back here.
One aspect I haven't heard about is safety. Like, what research has been done to prove that, you can use this in an airplane engine or, a wing?
Yeah, in fact, I made a joke earlier that nobody heard. I'll repeat it. That pedestrian bridge they built in Florida? That was 3D printed, and it fell and collapsed on top of all the cars. But it's a joke. It's not true. But my point is that it could happen. We could create things with 3D printing methodologies that don't have the resilience, that don't have the strength and engineering, and certainly not have the regulatory environment that controls the methods and make sure that it is capable of supporting whatever the weight or the span. Because I was looking online, there are bridges that are being printed. There are things, GE's making the wings, right? But they're not making the wings with a printer, they're making the molds with the printer, right? So people know what they're doing, but somebody could screw up, right? Anybody want to talk about that?
I'd like to say,
Yeah.
make a comment on that. You remember, many of you know that the airplane, when it first came out, and I'm old enough to remember, there used to be crashes all the time. And what did they do? For every failure, they went and they figured out why it happened and they fixed it. I expect there's always going to be that kind of evolution on any new technology. There's going to be failure, and we're going to learn from the failure, and we're going to make it better and better as time goes on. And one other thing, if I may have, I had the phone. Formlab is very interesting, the work you do, and you were talking about how, the expiration of patents as the company Formlab, I don't think would be in existence if that didn't happen. I mean, Chuck Hull's how did...
It's about 20 years.
Yeah, but you say you have very low cost. 3D systems could compete with you. Apparently they don't. Is that right?
Yeah, I think it's expectations. Yeah, sorry,
Yeah,
the microphone. Yeah, I think some of it's like expectations about the market. Nobody was in this affordable SLA space. We moved into it. There's a lot of legal stuff around that. There's a documentary on Netflix called Print the Legend, which covers some of our back and forth around patents. And yes, nothing is to stop other people doing this, and there are more and more affordable resin-based systems coming on the market. So for Formlabs, it really was just about being the first to do it. We kind of had first mover advantage, and we've grown an incredibly strong company that not only make hardware, but we make materials and software, and we have an incredibly strong support and services for it. So yeah, while there may be like low-cost competitors coming out from China with products that look exactly the same, You know, we've built a really strong company, and that's part of the thing with 3D Systems as well. They have a huge company, and to suddenly change and suddenly be nimble or suddenly make products more focused on the consumer market and needing much lower overheads in their operations that you need to support a product that's $3,500. You know, some of these big companies, you pay like $10,000 service contract a year, and they have an engineer who shows up and they'll fix your printer, and you just pay that every year. You know, versus with us, we had to create a whole system where you basically troubleshoot by email. We might send parts. We have like repair manuals. If your printer breaks, you just send it back to us. Like, it's a very different structure to support and service a low-cost product. And I think that's why it's hard for big companies to suddenly start doing something that's not coming naturally to them. But yeah, I mean, I think you see stuff coming down. I was just at a jewelry show, and there was a 3D Systems wax printer that's $50,000, and I was kind of like, okay, like it's starting. Yeah, they're coming down. They're doing what they can. Yeah.
So, any other yes?
How eco-friendly are the products that are being used?
Yeah, the materials.
The materials,
Yes.
are they toxic or?
Gerard, would you like to address that?
Actually, chocolate is absolutely quite nice for eco-friendliness.
Is that why you ate it?
I hope so, yeah. So, and also metal printing is absolutely, I guess, nice for this. Probably you have some problems with plastic, but nevertheless you use these plastics anyway. So the problems are not new. The same problems are with the products that we used before, and the resolutions is also kind of the same.
Anybody want to add to that?
There are a lot of resins that are coming out that are untested resins. They're new materials. I agree that materials that exist that you're using in technologies, it's just a new processing technique. ABS is ABS, whether or not it's 3D printed or injection molded. These new resins that are coming out, a lot of them have carcinogenic potential that we know nothing about. It just hasn't been studied because they're completely new materials. I'm not trying to be the boogeyman, but who knows? We haven't studied them well enough, whereas existing materials to the point of metals, a metal is a metal whether or not I weld it, sinter it, melt it, forge it, whatever you want to say.
Yeah, I think the professors, we've been referring to him, I mean, made the example of like UV polymers have been used in fillings for 20, 30 years. Like these are new formulations, but again, the technology has been around for 30 years. All materials ship with a safety data sheet. So you can learn more about the hazards. I will say on the cutting edge of new materials, there's really crazy stuff that can be done, but the materials get more toxic, and obviously it's about the benefits trade-off. So yeah, I think it's not that, it's not that dark a picture. I think a lot of these polymers have been used in different industries for many years. Like the solar industry, there's a lot of UV coatings that are used in automotive coating and all this other stuff. And yeah, I mean, 3D Systems or Chuck Hull's SLA technology came out of him working at a UV chemical company. So not strictly untested. There is regulation. It's not the Wild West. For example, the polymers being used in our biocompatible resins have gone through rigorous certification, and they come with like biocompatibility certification with them. And we actually manufacture those with a third-party manufacturer who has 20, 30 years experience in the dental industry.
Cool.
I was just going to
Yes, right
say...
there. Oh, did you want to add?
Well, yeah, I was just going to say that, and if you're printing at home or printing how we print, which is a lot for kids, and you're like printing at home and you have a hobby printer, most often you're using PLA, which is polylactic acid. It's a starch-based plastic. It's actually not biodegradable in the traditional sense, but it's fairly non-toxic, and it's not so bad.
But you do tell the kids don't put it in your mouth.
I always tell. That doesn't stop them.
No way. No way. But hopefully it's big enough that it won't block their airway.
Actually, we used to have whistles, and we had to take them away because every single kid.
Tell me about it. Tell me about it. Rob?
So one of the new big areas in 3D printing is tissue engineering. Actually, biological materials and trying to create organs. And there's a fellow by the name of Anthony Atala who claims he's made a bladder
a human bladder that's been implanted, and now he's working on a human kidney. Could you comment on using tissue engineering with cells to make biological materials and create human organs?
And that's different than making that fake ear, right? This is actual tissue.
This is live biological materials.
So who here is up on this subject? So HRAYR says he wants to tackle this one.
Well, actually, we have an institution in Armenia trying to kind of implement these technologies. For now, there are also possibilities to print muscles that just shrinks because of electricity. So it opens quite huge doors for medicine, and this is one of the probably most commercializable areas in 3D printing. So it is very useful, and it can save lives.
And that's a lot with prosthetics and things that, you know, limbs and things like that. But he's talking about organs. That's really challenging, isn't it?
For sure, for sure.
Yeah. And who knows?
Yeah, I think this is like really, really cutting edge 3D printing. And yeah, like all I can comment is like super exciting. And in terms of revolutionizing, I think that's, for me, like this very aspirational thing that I'm super excited to see how it comes out. One of our early materials science lead, Formlabs, actually is now doing a postdoc at Jennifer Lewis's lab in Harvard with the research thesis of printing the human brain. So probably, you know, setting himself the highest goal in terms of what organs could we try to print, you know, and that's a 10, 15 year horizon, I would say, in terms of this stuff coming together and being meaningful, but it's pretty cool.
And what I think is interesting is the way 3D printing isn't just 3D printing. It's a different way of thinking and conceptualizing. And there was a TED talk where they were talking about burn victims and how when you receive a burn really severe, you have several layers of dermal layers, and you just cover that with one type of cell, and that tends to create really bad scarring, and it doesn't adhere well. Well, what if you could scan those layers and you knew which layers were where, and you could just then send over cells of each dermal layer into where they needed to be, and you could have significantly less scarring and better healing times and things like that. So it's not even just, oh, here's a printer and something I can print. It's a different way of conceptualizing additive manufacturing.
Oh, yeah. We would encourage your companies to consider Armenia as a place to innovate, and we have a few people that might help out. What do you think? All right.
We are all open, and we think that working together with international society, being open and free in terms of freedom, is one of the main possibilities for us to be integrated.
Cool. Lily, you're in the back. You've been working in 3D printing. Tell us a bit what your question is.
Yes, I'm a designer and I had an experience of both. So I work in an architecture company in Boston, but also recently spent time in Armenia and collaborated with the fabrication lab in American University of Armenia to 3D print a couple of architecture models and experiment a bit. So just I have a suggestion and a question. According to my observations, Armenia has both interest in 3D printing and some of the 3D printers accessible in some of the universities. So during your presentation, you mentioned that people have access to 3D printers but don't have education or 3D printing experience to know what exactly they want to print. So there's a little bit of lack of education. I have seen some of the fabrication labs in several institutions that don't run at their capacity. Sometimes they sit there for days, so they're underutilized. So we have a lack of a little bit of educational workshops. But also I have seen numerous number of designers that want to print and they want to experiment. They're arts and products, they want to prototype, but they don't have a publicly available fab lab in Yerevan that would be accessible to people who want to work freely. So that's observations recently in Armenia. And the question would be, because running a 3D printer also requires some troubleshooting and constant supply of the materials. Which of the current companies have already presence in Europe or Middle East and have an easy accessible paths to troubleshooting, material supply, etc., or interest of expanding in Europe and Middle East?
I think this question is to me. There are some printers that are theoretically available for anyone, but those are not in garages, you know. So there is no restriction, but nobody knows about it. Let's say this way. You can go and just find somebody and say, you know, I want to make it, and nobody will stop you, practically. But if you want to print many of those items, then probably you will have problems with supply of materials. Materials are coming from abroad. Usually they are being bought in Europe or United States and being sent because, you know, the consumption is very low. And you need a kind of reactor for the people to understand how to work with it and what they can do with it. So now there's a program that just shows and educates K-12 students how to work with this. It means probably in 5 years those students will have their idea and startups working on this. And of course, to just make this process faster, we need just, as I said, some kind of success story, so everybody would see that those guys could go and implement in industries, in all these industries that were mentioned, the 3D printing technology. For example, jewelry already uses it in Armenia. So if you go to buy something, they will ask you if you want some modifications, and they will print it for you. And then, just to give you an example. So partially it is ready in Armenia, but there are troubles of understanding how to communicate all this and work as community. So, you know, if somebody has something, he thinks that he owns a very precious thing and he don't want to tell about this. This is usual, I guess, for many, but not for garage space. So
what do you think about the potential to bring key people to come and be trained and develop techniques and experience here in the United States? Is that important to do?
It is important. It is very important. Of course, they have to just see what kind of technologies there are. But the most important thing is also to have these facilities
in Armenia,
working in Armenia.
Yeah, that's got to go both ways.
Yeah.
And is it true we're now printing domics for Gyumri? Is that right?
Domics for Gyumri. Well, a metal one with metal printer.
That'd
actually,
be nice.
yes.
So I don't know if you know, we had a big earthquake, and the people are still living in boxcars or whatever containers, Quonset huts containers. So that's where we would like to have some.
There is
3D printed houses.
A story that actually we have one of these bombs that is just printing this garage, a little garage.
No kidding.
It's a joke.
I'm sure it's a joke. I'm sure it's a joke. Anybody have a burning question they want to get out? I'm sure everybody does, right? Jack, I'm going to hold yours. Way in the back.
So it isn't so much a question, but an invitation.
So get the microphone.
Well, I got to
that's
run around
that's
with it now.
What about the other question?
He wants to be able to hear your question.
sure. So it isn't so much a question, but an invitation. So Somerville High School has a publicly available Fab Lab. Everyone here is welcome to come and take classes there for free. The materials are for free, and it's one of the more radical things that Somerville is doing. In fact, we have a couple of Formlab printers there. We have some high school students and teachers who can show you how to use some of this equipment and the software. And so please come check it out. Thank you.
Great. That's a fantastic invitation.
My question is to AJ, the pricing on the SAM and the BAM and the SAM, either one, what is the price range? And also to Jennifer, in terms of the low cost. I think you mentioned $2,500, but what's the range? Because I noticed other printers in your presentation. So AJ?
So the SAM is an entry-level $10,000 machine. That's the automated small-scale 3D printer. We have a couple of different products within the SAM series. I'm not going to name those prices because they're not launched yet. The BAM is a 6 to 7 figure capital equipment expenditure, but this is a piece of equipment that's designed to last 30 years. It's using our core gantry system from our lasers, which have been in the market for over 40 years, and it has a 3D print head on that gantry. Again, it varies. We have a couple of different BAM models. We have different size BAMs. That's why it's hard to put an exact price on it, and there are add-ons to put onto the system. So these really are kind of custom installations at that scale and at that price point.
Yeah, so the Form 2 retails for $3,500 starting price. And I showed an older version of the printer, which was the Form 1. We actually don't sell that anymore, but we maintained the price as we brought out the new system. So yeah, to the question about other companies coming in, we sort of try to stay pretty competitive on the pricing. I showed a larger printer, which is the Fuse 1, which is a different technology. That's the powder-based nylon printer. That's starting at $10,000, but that's not available yet. We're just taking pre-orders right now. Yeah.
So is there such a thing as 3D printing in the cloud?
Of course there is.
Of course there is. Everything's in the cloud, right?
Yeah, I mean, more from the software perspective.
We don't really have to have these machines. We don't really even have to have the software. The cloud hosts everything, and we just shoot our designs up to the cloud, right?
Well, yeah, one application of that I think is relevant is 3D Hubs. So that's a great website that's created this international network where people can list their 3D printers. So Somerville High School, for example, might list that they have a printer available. And then you can basically search for printers near you or not near you, and you can send a 3D model, and they will, it's a totally open marketplace. People can list their own prices, and they can print and ship you stuff. So that's a good place to start if you do have something you want printed.
So can we print our refreshments so people can go and enjoy some food and drink? Is that cool?
I think we can
All
do
right.
it.
Okay, with that, I'm going to thank our panel members and appreciate the time they took. You can see they were working for years to create those presentations. And Chris, he worked for months trying to create his. I just never saw it though, Chris. What happened? Anyway, cool. The audience too, I'm glad you came out. This is a little bit of an esoteric technical subject, but I'm glad you're interested and I appreciate you coming. And hopefully you tolerated my jokes. But please take advantage of the refreshments. Elisa, did you want to say anything in closing? By the way, does anybody know where we are? You familiar with this place? If you're not, there's a guy here, AYVAZIAN, who will explain it, but this is a really unique institution, and the 3D printed books that are all fake on the side here many of them are first editions, and there's all kinds of stuff in here. So this is a really cool place. Thank you for coming. And our panel members are available for Q&A, and I'm going to hold them to their commitments to participate in Armenia's development as well. Thank you.
So they have labs that you can just get some time to come over and... Okay, ready to work.